So good afternoon. My name is Tim Frey and welcome to our Sustainability Forum. This is a fantastic response, and we have found that our clients are increasingly aware of their ecological footprint and are coming up with inventions with more and more green credentials. And both supply and demand decisions are now commonly directed by sustainability credentials. So this highlights the importance of sustainability to everyone. And so to inspire you further on your journey in this regard, we decided to launch a series of forums to be run throughout the year. For our first forum, we are very excited to be able to introduce three excellent speakers here for you today who have already brought this to life. We have Andrew Stacey, George Mikorczyk, and Jerome Smith. Andrew is the owner of Avgo Biotech, whose mission is to become the leading European supplier of high purity food and pharmaceutical grade calcium carbonate from industrial eggshell products. George is a senior architect and Passivhaus designer at Archetype, and we'll be talking about how it's possible to design and build zero carbon buildings. And Jerome is the owner with his wife Katie of Sarsfield's Chocolaterie. They'll be talking about putting the theory into practice and how to produce fantastic chocolates from a near zero carbon premises. The plan for the session is for each speaker to present for 10 minutes. At the end, they will be available to answer questions for 15 minutes. If you have a question, please direct it to the particular speaker on the chat, and I'll read out as many as I can in the time allowed. Now, at this point, I would be handing over to Andrew, whom I can't see has joined in, unfortunately. So I am going to hand over to George, if that is okay. So over to you, George.
Sure. Okay, let's see if the technology works. Can you all see a full-size screen? Great stuff. So thank you, Tim, for an invitation. As you said, we are architects, and yeah, very glad to be presenting our experience of designing to Passivhaus and net zero carbon. So this is me, and this is our own build house that we built about 4 years ago, although I'm not sure that Bernie is impressed. We've got three kind of base offices across the UK, so Edinburgh, Hereford and London. But since the pandemic, we also have sort of several creative hubs UK-wide. So we are covering the whole of the UK. Got about 68 employees and a growing number of certified Passivhaus designers. We're also striving to be majority employee owned company. So we provide a full range of architectural services, ranging from doing feasibilities, master planning, through to technical design, but also since 2019, we've launched a Perform consultancy, which does focus on kind of more technical side of things, including post-occupancy evaluation and yeah, similar kind of services to that. Oops, sorry, my keyboard froze for a second. Apologies. So the context, why do we need to focus on net zero? It's pretty clear we are in a climate emergency, and in 2018, IPCC, which is the Intergovernmental Planetary Panel on Climate Change came up with a report that clearly outlined the pathways to stay within the warming of 1.5 degrees from pre-industrial times. And where we are now is on top of this kind of peak right in the middle of the screen. And where we need to be by 2050 is down at the bottom here. So it's a big, big challenge and really focuses our minds. What it means for designing buildings is really we need to stop burning fossil fuels. That's the clear message. So we need to say goodbye to gas boilers, oil boilers, and embrace renewable technology such as heat pumps. And we need to do it from now. So how do we get there? I mean, we could either do business as usual, wait for the grid to decarbonize. We know the grid is getting cleaner all the time. There's more proportion of wind, solar, tidal, etc. So we could, keep building inefficient buildings, but what that would mean is there will still be a huge demand on energy, and we would need to offset that energy by a huge amount of renewables. Or we could do something a little bit more sensible, like radically reduce the demand in the first place. So have a small proportion of that demand, save a lot of energy, and generate only what is needed. So we obviously think the second option is the more sensible one. So I mentioned Passivhaus in the previous slide. Most of you have probably heard of Passivhaus. So it's a standard that guarantees quality of design and construction, provides comfort, focused on reducing the risk of overheating, drafts, mold, and poor air quality, and delivers huge savings on energy. And how it's doing that, it's doing it by efficient form, good orientation, using continuous insulation, have a draft-free construction, very efficient services, including mechanical ventilation and heat recovery, and optional on-site renewables. I mean, the potential for renewables, it has to be kind of pointed out, does vary from project to project. For instance, individual houses have more scope to put PVs on the roof, whereas a block of flats somewhere in the urban area, the scope will be a lot more limited. So there are limits to renewables on site. So Passivhaus, this graph kind of demonstrates the performance gap that kind of exists in normal buildings, i.e. non-Passivhaus. So there's a big gap between designed and in use, whereas the Passivhaus, the three little bars at the right-hand side, the difference between designed and in use is actually very small. And we know Passivhaus can be delivered at no extra cost as well, if it's kind of designed in right from the start. So when we talk about net zero, what does it actually mean? Well, there's a European norm 15978, which kind of defines the system boundaries. And these are split into various stages. So from product stage, where the materials are manufactured, through to construction stage, including transportation, construction and installation, through to use, and then end of life. And then we can also look at further boundaries if we look at the kind of life cycle analyses, which go beyond the kind of life of the building. So they would sort of include reuse, recovery, recycling, etc. So it's very important just to kind of, at the beginning of each project, to define your boundaries, see what you actually are trying to achieve. So as an example, I'm going to briefly talk about one of our projects that was a net zero energy, which is an eco-business center in Bicester that we completed a couple of years ago. So it's a new development, new business center as part of a new master plan in the northwest part of Bicester town centre. It's part of mainly residential development, but also kind of included a new primary school. So the brief for that was to deliver a flagship project, which would be zero carbon in use, achieve BREEAM excellent, using as many natural materials as possible, and provide a business incubator for about 125 people. Now, the brief didn't mention Passivhaus, but it all kind of alluded to being a Passivhaus Plus, effectively. So in terms of form, it's a very kind of compact, rectangular shape building with a kind of central atrium. It's all within the thermal envelope. We've got basically the facades are facing all four sides. So we had to really kind of think about how to limit unwanted solar gains as well. This slide shows the kind of section through the building, showing that kind of central triple height hub space, plenty of daylight coming from the roof lights, and then admin spaces along the edges. A typical floor plan, again, the central hub space, which goes all the way up, and then kind of flexible spaces along north and south. The typical elevations. So what you will see is a series of external kind of shading devices, timber fins, and that basically provides the valuable solar shading on all four sides. In terms of construction, it was a hybrid. So the contractor used a combination of concrete frame and timber infill panels. Obviously all super insulated on the outside to avoid any kind of thermal bridging. Here you can see typical detail of a foundation. The yellow color is a continual insulation kind of wrapping around that foundation slab. Again, kind of eliminating any thermal bridges. And the photo on the right hand side is just a demonstration how meticulous the contractor was in terms of taping up any holes in the air tightness layer that might sort of cause leaks. So it just demonstrates the kind of level of quality that is needed on site to achieve the workmanship and quality. Now on this project, as it was net zero energy, we had to provide the renewables on site, and pretty much the whole of roof was covered in PVs. It did present a problem in a way that the local energy network wasn't actually strong enough to take exported electricity, so they actually had to upgrade the network, which is quite interesting. So there are challenges with these new approaches. Yeah, a couple of photos of the completed project. So it was Passivhaus Plus, which means net zero in use. Just a few more kind of photos from the interior. I think it's a lot more occupied these days. Well, not these days because everyone's working from home, but they've got a lot more tenants since taking the photos. But we also need to talk about materials and how much carbon is actually embodied in materials. So a picture on the left is a typical cavity wall construction using concrete blocks, some sort of foam insulation in the cavity, and brickwork facing on the outside. And the photo on the right hand side, obviously a lot more natural materials that can also be used in construction. So you can all guess which materials have more embodied carbon. Now, what do we do when we want to kind of find out about embodied carbon? There's a very useful database called Inventory of Carbon and Energy Database that forms a basis for carbon analysis tools. And the graph on the right-hand side is a snapshot of embodied carbon of various construction materials. So as you can see, aluminium is one of the worst offenders on the left-hand side. But what's also worth pointing out is the overall quantity that's usually used on projects. So although aluminium is the highest per kilogram, in overall terms, aluminium is used quite sparingly in projects. So it's the green bar, for instance, that gives us an indication of how much of that material is actually used on a project on average. So it all needs to be sort of taken into account. Another very quick snapshot of insulation, for instance, very different results of embodied carbon when we talk about, for instance, polystyrene or other foam insulation materials, which are all the sort of yellow bars. And then if we look at more natural materials such as wool or cellulose or straw, they actually sequester carbon. So in a way, they are carbon positive. So again, something to really think about when we specify in building materials. And I'm just going to show a couple of slides of system which kind of embodies low carbon and material sufficiency. So when we talk about, for instance, timber framing, there are various options, including standard timber framing, CLT as kind of mass timber, or something like EcoCon, which is a twin stud timber frame system, pre-insulated with straw. And it is actually the system that we used on our house here. So very highly efficient product that uses natural materials, is fully recyclable at the end of life. There are no kind of chemicals involved, and has a cradle-to-cradle certification as well. So it is fully recyclable at the end of life. We also used clay plasters. So again, a very natural material with low embodied carbon that at the end of life can just simply be reused or buried in the garden, because that is what it is. Again, an example of an insulation that takes papers, recycles the cellulose, and it can be blown into construction and the final product. So thank you very much. I think that was about 10 minutes.
Thank you very much, George. That's brilliant. It spurred us all on, I think, into looking at our surroundings and looking at the buildings that we're in, and how much impact we're having on the environment. And moving quite quickly onto that one, I'm now going to move actually on to Jerome Smith at Passivhaus Chocolaterie, because it looks as though Andrew has not yet joined. So over to you, Jerome.
Hi.
Hello, welcome. So my name is Jerome, and this is my wife Katie, and we started Passivhaus Chocolaterie about 6 years ago. We started the build about 6 years ago.
Share the screen.
Sorry, 2 seconds. We agreed on a piece of land about 6 years ago, and then sadly it took a little bit longer than we expected to actually build it, through lots of different reasons. But that is effectively our finished product. We started making chocolate about 10 years ago, and decided that we needed to do something other than markets and shows. So it's kind of all in. And if we fall flat on our face, then at least we've given it everything that we had. For a sustainability side, the more we got into looking at doing the build, it became massively important. To me, hugely important. To my wife, she needed a little bit of persuasion because of certain things that we used with the building. So
it was the money, the capital side of things that for me was really difficult to get my head around.
Yep, indeed. So our building's about 198 square meters. and as the things that we had, or that we tried to incorporate into the build, was what actually we've just heard a little bit about from George, to do with like straw walls. So we use straw walls. We've used a triple glaze heat repellent glass, because being a chocolattery, it needs to be a very, very stable environment. We can't have massive fluctuations in heat in the building. The roof tiles were also quite important to us. The solar panels, again, the closer you can produce your own power is a massive, massive gain on so many different levels. Internally, things to do with what screed we used. So you can use a concrete screed, or you can use something other than concrete, which we ended up using, which we'll talk about a little bit later on. And obviously the lighting and heating is massively important, so how much energy you're using throughout the year. So there's just a few slides showing again what George was talking about, the actual frames. So so effectively it's a glulam frame, excuse me, with straw compacted into it, and it's a modular system. The walls are constructed off-site, and then they're delivered on a lorry, and effectively it took about a day and a half to go from a slab to walls and trusses, and then for the next 4 days everything was tied in, and then the next stage went on to the builders. Builders came and started doing the membrane on the roof and getting that prepared for the solar panels. As I said earlier on, the really, really important thing for us for the building is that the building really could not have fluctuation in temperature. It's got to stick at around 18 to 20 degrees throughout the year. Otherwise, to make chocolate does not work. For us, the walls, the best way that we could find to build the walls was through straw for sustainability wise. So everything's fire regged, everything's fire rated. The company is actually a company called Modcell who we've used, and they've gone through all their building regs and fire regs to get everything passed. They've also been using Bristol University to develop their product. They've been making walls for a good number of years now, but yeah, really impressed with them, really impressed with really everything to do with them. Then our windows, they had to be, like I say, a heat repellent glass, so it's a triple glazed heat repellent. Company from Gloucester, a company called Roarington. We specifically didn't want to be using UPVC windows, so we went down the road of a wood-clad window. So on our roof, we managed to try to incorporate as many roof panels as we could. So we have effectively a tile edge around the building, and then the inside of the roof are panels. So there's no tiles underneath the panels. Effectively, they're recessed into the roof. The tiles, I'm trying to think. I can't remember why we couldn't go edge to edge with panels.
No, I can't remember why, but there was a reason why we couldn't.
So we had to incorporate some tiles as well. So the tiles are reconstituted tile, which effectively gets smashed up, and then it's effectively it's got a resin in it.
So it's Welsh slate.
So it's a Welsh slate roof tile, which we're really happy with the look. In reality, they were yeah, pretty difficult to do, but to know that actually what you built out of is really important.
Yes, it's waste materials from Welsh slate that's then been reconstituted with resin into a tile. But we also had real big problems because our roof is really shallow, actually. So we really struggled trying to find a tile that was able to withstand such a shallow roof.
That in turn is also, that sadly created more problems for us to do with the fact that we're having to incorporate solar panels with some tiles, and nobody actually wanted to stand by any warranty whatsoever with the roof. And this might just be where we are, but when we've tried to incorporate certain things into our building, I think we definitely sadly hit some walls, some stone walls. But I think it just depends on how determined you are or how determined we were, and how important it is to think out of the box and actually try to start making a difference. Yeah.
So I don't think we've said how many. So we have 100 solar panels on the roof. We have 50 either side. And
the way that the building is actually situated in the field is really important. So the architects designed the angle of the building so we're getting maximum amount of efficiency from the sun. So and that was also to do with the roof angle as well, to try to get the most sun that we could get from our panels.
Yeah. So I picked a really bad screenshot image for so we have these updates that you can see in the bottom right. That was a really cloudy day. I think you said on a sunny day
on a sunny day we can get up to about 30 kilowatts of kilowatt hours of electricity. Then you have the little center fellow that says 100%, and it just shows where the power is going in the building. So it either goes to our heating system, goes back to the grid, or we use it in the building.
Running a cafe, in the summer, we can easily run the tea rooms and chocolaterie with all of the power that we need for the coffee machine and everything from just the roof. Yeah,
everything. We seem to be producing about, or we're using about a third of our power. So about 2/3 of it gets kicked down back onto the grid. Long term, it would be nicer to be able to store some of that power, but at the moment we aren't, sadly because of cost. So internally we use something called Givlon, which is a screed instead of a concrete base, which is a massively 98% recycled material, which again is just that happily actually was from our builder, not us, which is pretty cool. Our biggest problem that we found with Givlon was its drying time was very, very slow. So it took a long time for it to dry. It took over 200 days for it to dry. But if you get enough airflow, which we didn't understand at the time, then that would massively help. Our heating system, so in the bottom left-hand corner, we have some heating systems, which is a company called SunAmp, and effectively it's a chemical reaction to produce hot water. So you have cold water going in and hot water coming out. That charges itself from the roof. Our biggest problem with that, sadly, we can't get enough heat to actually heat the building properly with what we have. And that was down to the constraints of actually our money. So if we could have done again, or if we had slightly more, then we could have changed that instead of the way we did it. That's an ongoing small problem that we have at the moment, but I do think we are getting there with the help from SunAmp.
Oh, sorry.
Jerome, can I give you sort of a couple more minutes just to
Yep.
We're on the last slide. If I stop This one, if you can get to it.
So internally again, so lighting wise, everything's got to be dimmable, everything's LEDs. So we're again just trying to cut down on the amount of power consumption that we're using, and which happily seems to work. Yeah, our general consensus, we're really super happy with what we've managed to do, and the amazement that people give us from knowledge of either the roof or what a floor is, or the fact that we've used straw to construct this. Yeah, really great.
Yeah, I think from me, I wasn't convinced initially because it was such hard work. So it makes everything more hard because you're going down a non-conventional route, or as people see, a non-conventional route. So it just makes it a harder process. But Jerome had the vision and wanted to do it. I think I would have probably given in, but I'm glad that we didn't, because we can be so proud of what we've done now, and the customers, when we talk to them, it just it's super nice. So yeah.
And the more buildings are built like this, especially businesses, it becomes progressively easier and easier for the next person. The next companies, it becomes easier, and then hopefully we'll stop building places in the way that seems to be the general consensus.
Yeah. So I think we're there.
Yeah.
We could talk forever about it.
Talk forever. And incorporating cork walls actually internally, really quite cool. That's kind of an ongoing thing which we're doing. Anyway, I'm going to be cut off.
Yeah. Thank you very much, Jerome and Katie. That's brilliant. Your passion is coming through there, definitely. And it looks as though Andrew has now joined us, and I'm going to unmute him, and hopefully he'll be able to join us with his description of Avgo Biotech. Over to you, Andrew.
I've got the screen, have I?
Yep, go ahead.
You can see my screen up there?
Yeah, we can see you. Yeah, you just need to share your screen with your slides on. So we can just see you at the moment.
Oh, we're going to see you in a minute. Right.
Okay.
Hey, are we there?
Yep.
Yep. Hello, my name is Andrew Stacey. I'm from Avgo, and we are solving problems in the pharmaceutical and the food industry. And this is a slide deck that's been used for raising money, so I apologise for references to tax and things like that. And if my computer actually, there we go. So I was supposed to be on first, so I thought that I'd put a little ditty in about sustainability and what it actually means. And from where I stand, it covers two things. One is the business economically viable, and can it go on forward? This is really relevant to where we are trying to raise money at the moment. And obviously why we're here is that there's depletion of the natural resources, and how can we maintain the balance? So Jerome was obviously talking about how we can build a sustainable building and heat it. We're taking a slightly different stance. And I'll explain that as I go forward. So we've all heard David Attenborough and the Cambridges talking about doom and gloom that's in front of us. And over the years, we've thought that perhaps we ought to be doing some little thing to try and contribute to making the world a better place, and following the line of these people. So at the moment, our view of the resources of this world, and it comes into the way we're trying to market the business, is that we're out there raping the land through mining and causing great scars. Locally, perhaps we can reflect on the big white scars in the Peak District, where they're mining chalk for concrete manufacture. And then there are industries that are belting out huge quantities of carbon dioxide. And we're all happy to buy stuff from China, but we don't really think about how it gets here. And we've got a big ship here. We estimate that's probably 700 kilos of carbon dioxide for every ton of material on that ship. And if it comes by air, which PPE has been doing recently, it's even more. And we don't really worry about it. But where we are is the food industry. So did you know that 1/3 of all food produced globally is wasted? And that's 1.3 billion tons a year. I think that's a total travesty, and something needs to be done about it. I can't solve the problem. It's a governmental global problem, but we can make a small effort to try and do something. So what can we do? We can use resources better. In our case, we're trying to use resources that could be mined, but we're taking it from a waste source. We can reduce transport. Why do we want to transport stuff all the way from China? There's perfectly good industries in the UK and in Europe to purchase things from, and we should support local industry. Again, why support industry across the world? We can actually have both economic and environmental benefit to local industries. So our story. I met a man at a service station on the M1 and had a discussion about the egg processing industry. And we all know what the egg processing industry is. No, hadn't a clue. So egg processors take eggs and they crack them and they produce liquid egg that can be used in cakes, meringues, Aunt Bessie's Yorkshire puddings, or they boil them and put them into egg mayonnaise and Scotch eggs. That's very interesting. But the problem they've got is that they produce eggshells. And across Europe, there's 250,000 tons of eggshells that predominantly go to landfill. That's 250,000 tons. That's quite a lot, isn't it? And they all produce carbon dioxide. So it's just a degradation of the material in the ground. And also there are other toxic chemicals like sulfur dioxide and phosphates, which have an impact on the water course, the air quality, and generally are a problem. And these guys are spending over 25 million a year to put stuff into the landfills when it's something that they could actually use. So after a lot of deliberation and talking to people, we found that the pharmaceutical industry might be somewhere where we could sell this material. So as we all know, our tablets have got a lot of calcium carbonate in them, capsules, and various other materials in pharmaceutical industry. Their problem is that they mine this material generally in the Far East, and then they transport it across the world to Europe. And mine material, unfortunately, has toxic heavy metals in it. And overall, this is costing them over 40 million a year across Europe, which is a problem to them. So both on sustainability and corporate social governance level, they want to do something, and they certainly want to make sure they haven't got any toxic metals, or else there'll be a very large lawsuit. So at AVGO, we put our heads together with Nottingham Trent University, and I talked to an engineer called Mike Keast, and we've come up with a green solution to put the two industries together. So we can take the eggshells and produce a very clean and sustainable calcium carbonate, which is produced in a circular method. So basically, we're looking at the egg industry and the pharmaceutical industry and banging them together and coming out with a sustainable and circular calcium carbonate, which is green. That sounds pretty good, doesn't it? So this is a quick overview of what we do. So we take eggs, we put them into our plant. It might be called a biorefinery by some people, and we're producing material for you to ingest in your drugs. We're also producing waste material. So eggs have got membranes. We could use that in bone and joint treatments. It's something we haven't looked in, but we're thinking about it. And the contribution of Mike, the engineer, was that he's taking all of our waste products and converting them to input chemicals. So that means that we're totally circular, and from a cost point of view, we've dramatically reduced our input costs, and also we're not moving large trucks of chemicals up and down the motorways and across the country. We're also producing this material locally in the UK for UK markets. So we're not having problems with carbon footprint of importing and moving things from abroad. So that's what we've done with the calcium carbonate, but we're also looking at other materials. And the emphasis is that we can produce chemicals that we're buying from foreign parts just as well in the UK. And we've actually had discussions with people who are unfortunately suffering from both COVID and Brexit. There are difficulties getting chemicals out of Europe. There are difficulties selling chemicals into Europe. And why not produce them in the UK? So a second project we're involved in is taking waste from mushroom plants. And we're doing exactly the same thing. We're going in, we're taking the mushrooms, treating them, getting out the useful resources that are in them, and we're making supplements and antimicrobial and anti-inflammatory products. And finally, we've got a project with apple waste, where we're doing the same. There's a lot of material in apple waste. Yes, you could feed it just to your pigs, but we can actually do a lot of things that will help people. So we actually got on this project because of COVID. There's material called polyphenols, which has got antimicrobial and antiviral activity. And actually the waste from the overall process makes bioplastics. And as an aside, we also were riding the COVID wave and found that brewers' waste could be turned into bioplastics. So we're looking at a personal protection equipment for medical and other applications. The emphasis being here that we are working with a biorefinery, which ultimately takes a resource that is generally wasted and making better use of it. We're reducing the problems with landfill and cost, reducing carbon emissions, and generally we're helping the environment. Whereas on the other side, we're potentially improving the corporate social governance of our potential customers, increasing UK technology, and generally improving business in the UK. And essentially, we're here to try and make a small contribution to make the world a better place for you, me, and our children. And that's the end for today. I'm open to questions.
That's brilliant, Andrew, and fantastic presentation. Thank you very much. Glad you could join us in the end. That's really good. I'm aware we've gone slightly over there, but thank you very much to Andrew, George and Jerome for those insightful and inspiring presentations. We can take a few questions. I've got a question for George. So George, this is from Jeff Lucas. What effect will the Grenfell inquiry have or is having on the use of natural, sustainable but combustible building materials?
Yes, that's a good question. I think what we are seeing or starting to see is reluctance of people involved in procuring buildings to use combustible materials within external wall assemblies. So on more recent projects, especially kind of medium to high rise, we are seeing shying away from use of the likes of timber and foam-based insulations. So it's more the kind of non-combustible type of materials. But I'm sure the building regulations will be updated fairly soon to kind of reflect the findings.
That's great. Thanks, George. Andrew, what would you say are the biggest challenges to, getting your product into the marketplace?
Currently, it's not necessarily getting it into the market, it's finding the funds to be able to do it in the first place. We also need to find markets that are willing to pay for waste products. Unfortunately, as soon as you use the word waste, people will expect it for free. So that's one of the problems. We also have issues with where does it become waste? And we have to ensure that the product is controlled all the way through the process, so that someone can't come along and say, actually, it's a waste product. It has to be a food product throughout the process. And then we can raise it up to a pharmaceutical product. So at the moment, it's funding, whether we can get the value that we want from waste materials. Yeah, it's really the main problems at the moment.
Okay, thank you. I don't see that we've got any further questions. So unless anybody wants to suddenly jump in with anything, it's probably a good time to draw everything to a close and say thank you again to Andrew, George and Jerome for their brilliant presentations. And thank you to everybody for attending. We will make this recording available on our website, so that I think there was one question or note further earlier about that. So we'll make that available on our website. Our next forum will be in March and is going to feature James Napier from CBN Expert, who has kindly agreed to talk about their software, which measures and manages carbon footprint and identity. So remember to keep a lookout for the next session, please, and we'll send you a link to that when it comes in. So thank you very much, everybody.
Right, thank you.
Thank you.
Thank you.
George. Thank you, Andrew.
Thank you.
Thank you.
Thank you.